this is kind of what I would have put together here. 2 sine of theta plus 1 is equal to 2. Please write that down. Now, our goal today and on Monday is going to be to solve trigonometric equations. I will give you the basis for what we're going to do, and it is this. 2x plus 1 is equal to 2. How would I solve that equation? Divide by 2. Does everybody agree I get x is 1/2? Okay. We can do the same thing with equations like this. It's just that instead of an x, we have this thing, we have this sine of theta. And so in this situation, we will subtract 1 from both sides. And when we do, we get 2 sine of theta is equal to 1. Once we get 2 sine of theta is equal to 1, we divide both sides by 2. And instead of x equals 1/2, we have sine of theta is equal to 1/2. So the basis for our answer today will be trying to figure out that. Would everybody agree that the first steps were really easy? This step is just a little bit more challenging, and but we can do it. And in order to do it, we need to understand something about our 4 quadrants. And this is something you will want to reference. Here, the coordinates are positive and positive. How about over here in quadrant 2? I have negative, positive. How about in quadrant 3? Negative, negative. And in quadrant 4, positive, negative. Is everybody okay with that? Now, I'm also going to ask you to remember that on the last test, if we were given x, y, we said that sine of theta was it the x value or the y value? Sine is y, very good. What was cosine of theta? That was x. What was tangent of theta? Y over x. Good. So this is the very important part, folks, that you have to get. If sine is the y value, is sine positive or negative in the first quadrant? Positive. Is cosine positive or negative in the first quadrant? Is tangent positive or negative in the first quadrant? I will give you this on the test so you can know which ones are positive. I move over to the second quadrant. I have positives, and this time we will pick up negatives. Is sine positive or negative in the second quadrant? Why is it positive? Sine is positive. Why is it? Because sine is the y value, and you can see that y is positive. So is cosine going to be positive or negative? It's going to be negative. Cosine's negative over here. How about tangent? If tangent's y divided by x, will tangent be positive or negative? Tangent is negative. I move to the third quadrant. Knowing what you know now, can you predict for me which one's going to be positive? Which one? Why will tangent be positive? If you divide 2 negatives, you get a positive. That's okay, Baller. Thanks for taking a chance on that one. And so sine of x and cosine of x will, in fact, be negative. And finally, when we get to the fourth quadrant, can you predict which one's going to be positive? cosine of x. And the negative will, in fact, be sine of x and tangent of x. What's that? We'll show you why. Some people wonder, how do we remember this? And there's a kind of an acronym that people will use sometimes, and it goes like this. All students take, and I didn't make this up, this came out of your book, calculus. It's all going to take calculus someday, right? Yes. Awesome. Great. So if you look, all of them are positive in the first, aren't they? Which one's positive in the second? Sine. So you have S. Which one's positive in the third? Tangent. Which one's positive in the fourth? Cosine. So you have the C. So this is why we use this piece right here. We came up with sine is equal to 1/2. Can somebody tell me in which quadrants is sine, is this positive or negative? Which quadrants is sine positive? First quadrant and second quadrant. We draw two reference angles because that's where sine has positive values. We're not going to just have one solution for sine. You're going to have two solutions for sine. Now, in order to find them, take out your calculator. Sam's got to go. Take out my calculator. We are going to work in degrees. Please make sure that your calculator, if you press mode, please make sure that you're working in degrees. If you're trying to find an angle, we don't press sine. What do you press? Second sine. And you type in 1/2. And when I type in 1/2, I get 30. So that means you put 30 degrees for your reference angles. And now we give the answer. Can somebody tell me, what is this angle right here? 30. Can somebody tell me what's this angle here? Not 30, 150. Watch what happens, folks. If I take sine of 30, I get 1/2. And if I take the sine of 150, I get 1/2. In order to find both of them, you have to be able to set up your reference angles in the right quadrants. So that's the only trick question. Yeah. So I want to be clear. Suppose I came up with 76 degrees. I still would put, I just put it anywhere. I just use it to be, it doesn't matter if it's to scale or not. So suppose this answer instead of 1/2, suppose this piece right, 2 doesn't work. I'll teach you why later. Let's say 1/4. Can we say 1/4? So I go sine inverse of 1/4. And when I do that, I get 14 degrees. So I have 14 here and 14 here. So it'd be 14 and 168, or 66. Let's do a couple examples now that you've seen it, and that's going to help us so we have success on Monday. Okay. Let's try another example that's very similar, and so we'll do 4 examples here, and I think that'll really help you. What do I do to solve this one? What should I do to both sides? Add 1. And what I do, I get 2 sine of theta is equal to what? Negative 1. Now, what do? Divide by 2. I have sine of theta is equal to negative 1/2. That's what we're going to try to decide now. I draw my quadrants. This is the process that you'll have to go through. Where is sine negative? Both the bottom ones. Sine is negative here and here. You can always look at your notes. I will give you that part on the test. So I draw 2. This is where people make a mistake. And there are multiple ways of doing this, but this is what I'm going to show you. Don't type in, when you go second sine, don't type in negative 1/2. You've used up the negative by determining it's in the third and fourth quadrant. Just do sine inverse of 0.5. What do you get? 30. So this angle here is 30. This angle here is 30. But those are just reference angles. If those are just reference angles, who can tell me what is this angle right there? Good, 210 degrees. And that angle is 330 degrees. So if I type in sine of 210, you can see I get negative 0.5. And sine of 330, I get negative 0.5. Because you weren't here yesterday. So, but if you look, if this is a 30-degree angle, we go 30 degrees past 180. Then 30 minus from 360. That's it. We try a different one. 5 cosine of theta plus 2 is equal to 3. 5 cosine of theta plus 2 equals 3. That's what we're going to solve now. We'll do 2 more of these examples together after this. What do I do first? Subtract 2. I get 5 cosine of theta is equal to 1. Now what? So cosine of theta is equal to 1/5. What I must decide is, where is cosine positive? Where is cosine positive? First and fourth quadrants. So we just go ahead and draw 2 reference angles, one in the first quadrant, one in the fourth. I have to figure out what my reference angle is. So on my calculator, what do I press? Second cosine, 1/5. 78.46. What's this angle right here? 78.46. How would I get this next angle here? (360 minus 78.46). Very good. And I get 281.54. No, always the x-axis. Always the x-axis. Try 2 more. What do I do first here? Subtract 5, and I get -6 tangent of theta is equal to -8. Divide by -6. Tangent of theta is equal to what? 4/3. Is that positive or is it negative? It's positive. in which quadrants is tangent positive? First, third. First and third. What do I do now? I go second tangent, and I type in 4 divided by 3. Whoop. And I get 53.13. Always put the angle between the angle and the x-axis. So what's this angle right there? 53.13 degrees. How would I find this angle right here? (180 plus 53.13 degrees. (233). You try this last one on your own. Go ahead. -4 cosine of theta plus 1 is equal to 4. See what you can do. Okay, what do I do first? Yep, so -4 cosine of theta is equal to what? 3. Divide by -4, and we've got cosine of theta is -3/4. So at this point, and this is where people start to fall apart, and that's okay. That for us to make mistakes right now, we just want to make sure that by next week we start to tidy this up. But do I write down where cosine is positive, or do I write down where cosine is negative? Negative, because it says it's negative. Where is cosine negative? Second and third. So those are the two places I draw my angles. On your calculator, do not do this, folks. Watch what happens. If you include the negative, when you do cosine inverse of -3/4, and you can see it gives you a pretty nasty value, doesn't it? Yeah, so you used up the negative when you determined which quadrant you were in. You're done with the negative. So just do cosine inverse of 3/4. And when you do that, you get 41.4. 41.4. So this is 180 degrees. So what would we do to find this angle right there? Yeah, you'd subtract and you get 138.6. And then you would add to get 221.4. I'm sorry, ask that again. That's by chance. Sometimes it works out, sometimes it doesn't. But the problem is if I give you the 138, a lot of times people don't know how to find that. But if I give you the 41, then you know how to find both of those. Good question. You're able to find this one, but then it's tough to figure that one out, isn't it? Okay, I'm gonna answer that question for JJ. You guys, so on Monday, what I will do is you can see that some of these problems are a little bit more involved, right? So this used to be a semester course. We have more time to get to some of them. I'm going to redo our worksheet for Monday and have us practice the basic problems first before we get to ones that are a little bit more challenging. Trust me, if you can make it, the most challenging part of this, what we're doing, it's the first day. You'll feel better on Monday and solving these equations. People generally do very, very well with them. These are points you can get on your test. So for your test, you're going to graph, sine, and cosine, and you're going to solve equations. Those are the two things. Okay.